Welcome to the Forest Analytics Landing Podcast. I'm your host, Matt Russell. In this podcast, we'll talk about how data and analytics are transforming the forest products industry. We'll share how a research-based approach to analytics can empower your forestry organization to make better decisions with your data. Hello, everyone. Welcome to the podcast. Today, I want to talk about statistics and statistical significance. I think this is a really hot topic in really the world of statistics, but also I think it's starting to filter down into the disciplines of science, including forestry. And so I want to read today from a post I wrote in 2019 called "Should Foresters Keep Saying Statistically Significant?" And so I think it's an important article that really gets to the point of, what is significance nowadays? In a world where a lot of analysts aren't using things like p-values and hypothesis tests anymore, what does that mean for us in forestry? And so I'm going to go ahead and start reading this article. The article is called "Should Foresters Keep Saying Statistically Significant?" The statistics community has had a lot of discussion in recent years about the role of p-values and statistical significance. So what does this mean for forest biometricians and analysts that have traditionally used p-values and tests of significance in their daily work? The American Statistical Association's August 2019 edition of their magazine Significance has a number of great articles on the topic. They even refer to this as the S word. What are p-values? For many foresters, we learn that p-values are the probability under a statistical model that a summary of the data would be equal to or more extreme than its observed value. Frank Fries's seminal work in Elementary Statistics for Foresters presents the concepts of p-values and significance tests. He first mentions them when discussing the correlation coefficient of tree diameter and their age. He says, quote, "This test result is usually summarized by saying that the sample correlation coefficient is not significant at the 0.05 level. In statistical terms, we tested the hypotheses that R equals 0 and failed to reject the hypothesis at the 0.05 level. This is not exactly the same as saying that we reject the hypothesis or that we have proved that R equals 0. The distinction is subtle but real." End quote. For another example, we could compare the means between two groups. After collecting some inventory plots, a pine stand on a high-quality site may have an average volume of 25,000 board feet. A stand of the same age on a poor site might have an average volume of 18,000 board feet. We might conclude by saying that the difference between the two pine stands is statistically significant at the 0.05 level. The issues with p-values. So what's the issue of saying the two values for the two stands are statistically different? In 2016, the ASA highlighted that statistical significance is not equivalent to scientific, human, or economic significance. Assessing statistical significance is commonly done using the p-value as a threshold. A p-value can be small if the number of samples or measurement precision is high enough. A p-value can be large if the sample size is small or measurements are imprecise. A p-value doesn't measure the size of an effect or the importance of a result. So a p-value of 0.0001 does not indicate a more important result than a p-value of 0.045. This is where you might often hear someone say, "My p-value is so small, my results are very significant." The ASA went further by stating that the word statistically significant should be abandoned altogether. Their article describes the statistical significance and how that was never intended to imply scientific importance. So in short, any label of statistical significance on an outcome doesn't indicate that an effect is real. The atom approach for significance. Should forest biometricians and analysts stop using p-values? At a minimum, I really like the ASA's shortcut to remember atom. When thinking about traditional applications of p-values and significance, accept uncertainty. Be thoughtful. Be open. And be modest. Data are noisy in the real world. By accepting the uncertainty inherent in the data, we move away from categorizing variables and attributes as either significant or not significant. Practicing thoughtful data analysis allows analysts to assess their workflow and applications of their work. Are you engaging in exploratory data analysis on a project? Or are your results going to inform key decisions and a thorough statistical analysis is needed? Being open about your analysis stresses the importance of recognizing that subjectivity is present in any statistical analysis. This is also true when considering the role of expert judgment in the data analysis project and the interpretation of a project's findings. When communicating p-values, a practical tip is to present them as continuous values rather than dichotomized ones. For example, you can report p equals 0.04234, not p is less than 0.05. Being modest encourages you to think about how others might be able to reproduce your work. More broadly, being modest promotes the limitations of statistical knowledge in the larger discipline of scientific understanding. When to use p-values. Despite the issues and misuse of p-values, they may be useful in a few applications. Here are a few applications where foresters might continue to use p-values. Quality control. Is product quality and assurance important in your business? P-values could be used in cases where automated decision rules are required. This approach could reduce the costs, time, and effort without a product quality protocol in place. Variable selection and model fitting. Foresters often have a vast number of potential variables to use to explain the variability in a forest attribute of interest. How do we sort through those variables to create a meaningful model that can be easily interpreted by others? For example, consider a remote sensing project that seeks to estimate forest biomass from dozens of variables obtained in a LiDAR acquisition. P-values might be used in this case as a threshold to only allow a select number of variables to contribute to a final model. This can result in a model with few variables that have a lot of power in explaining forest biomass. It's important to revisit what p-values are and what they aren't. Forest biometricians and analysts may still find that p-value outputs are useful to look at in their daily work. Conclusion. There's been a lot of discussion recently about how p-values are misused. Forest biometricians and analysts should recognize their limitations, but still may use p-values in a few specific cases. I'm curious, how do you use p-values in your work? Do you say statistically significant when you're interpreting your forestry data sets? Thanks for listening, everyone. I hope you enjoyed this. I'm also going to share a unique meme that I saw presented by Matt Dancho. Matt is a data science instructor, and it's a neat meme that looks at a European rugby fan, and when he gets statistical results greater than 0.05, and then when he gets statistical results of 0.0499. And so it's an interesting take on this concept of statistical significance, and I'll share a link to that meme in the notes. Thanks for listening, everyone. Thanks for listening to the Forest Analytics Landing Podcast. For more information on how data and analytics can empower your organization, visit arbor-analytics.com.